Okay, part 3 of the radicals video. We're just continuing through things. Like I said, this is a big topic, so it does require quite a bit of explanation. And we just finished this example. We're continuing to do simplifying using properties. Let's see, we've got cube root of 24. You know what? I'm thinking maybe we could split this into cube root of 8 times cube root of 3, right? 8 times 3 is 24. But the cube root of 8 has a cube root, right? 8 has a cube root. It's 2. So this would be 2 times the cube root of 3. Okay, remember for each of these, as soon as I display it, you should pause the video and try it yourself, and then come back and see if you've gotten it right. What would you do for this one? Okay, so let's split for numbers and letters. And then further, I think I'd do the same thing. I would split that 24 into 8 times 3. And then since we're going for cubes here, I'd probably take cube root of a cubed. So that's going to cancel to an a, right? And then I would have cube root of just the one remaining a. So this would become a 2. This would be cube root of 3. This would become a, because it's a to the 3/3, which is 1, and then cube root of a. And if I combine everything outside, it's 2 times a. And then we have the cube root of 3 times a. So it's 2a times the cube root of 3a. Okay, pause this and try it. Okay, same idea here. Let's separate into numbers. Cube root of the x's. And we're going to try to find things that have cube roots. So 8 is a good one for 3. So let's say cube root of negative 8 times cube root of 5, because negative 8 times 5 is negative 20. And then let's split it this way. Cube root of x cubed and another cube root of x cubed, right? Because x cubed times x cubed is x to the 6. We would add the exponents, right? So we've got 2 cube root of 5, that's an x, and that's another x. So I have 2x squareds times the cube root of 5. I know it seems weird at first, but the more you practice this, the more comfortable it gets. Okay, this is going to seem a little weird, but you know, I can't take a square root of 128, so inside the cube root, let's split this into square root of 64 times square root of 2. Because at least we can simplify this into 8 square root of 2 on the inside. And then I can separate that into cube root of 8, cube root of square root of 2, right? And the cube root of 8 is a 2. And I can't really simplify this except to say that this is the 6th root of 2. So I could write it like that. 2 times the 6th root of 2, because it's 3 times 2. Okay, how about this one? Okay, what comes to mind to me is that 27 and 125 both have cube roots. So I would separate this into cube root of the numerator divided by cube root of the denominator. And then the cube root of negative 27 is a negative 3, right? A negative 3 times a negative 3 is positive 9, but times that third negative 3 gives me negative 27. And then I have 25 on the bottom. So I would have no radicals at all when I'm done here. It's negative 3 over 25. Okay, probably the best approach here is, since 75 and 3 don't have square roots, maybe combine those into one fraction. Because that's the square root of 25, which does have a square root. So the answer is just 5. Okay, I think that's enough of that practice. Now we've got to talk about what happens to get simplification if we have a fraction, but we have a radical in the denominator. A fully simplified expression cannot have a radical in the denominator. To clear that radical, you do a procedure called rationalizing the denominator. What this procedure does, effectively, is it moves the radical from the bottom of the fraction, the denominator, to the top of the fraction, the numerator. Okay, here's how it works. We're going to take this, let's say we have 1 over square root of 5, and we're going to multiply by 1. I'm just going to multiply by 1, okay? But I'm going to write that 1 a special way. I'm going to write that 1 this way. I'm going to write that 1 as the square root of 5 divided by the square root of 5. I could write that anyway, but I'm going to choose to copy the square root that's in the denominator that I'm trying to move. Because what happens if I multiply these fractions together, right? You get one big fraction, you multiply across the numerators, you get 1 times square root of 5. And when you multiply across the bottom, you get square root of 5 times square root of 5, which is the square root of 5 squared. But the square root of 5 squared is just a 5. right? Because the square and the square root cancel, and so that effectively moves that square root from the bottom to the top. So when you rationalize the denominator, you end up with square root of 5 over 5. So square root of 5 divided by 5 is equal to 1 divided by the square root of 5. You could take a calculator out and try those two things and see that they're the same decimal. But when we write as a fraction, we're not supposed to leave a square root on the bottom. So to move it, we do this procedure called rationalizing the denominator. And all it is multiplying by 1 written as the square root over the square root using the square root from the bottom. Okay? So try this one yourself. We're going to multiply by square root of 2, top and bottom, right? That's what we're doing to rationalize. What happens when we do that? Pause it and try it. Okay, when you multiply across the top, I've got 5 times the square root of 14, because I'm going to combine those back together again into 1. Remember, for simplification, I don't want multiple radicals. I want one radical. And the square root of 2 times the square root of 2 is just 2. So this simplifies to 5 times the square root of 14 divided by 2. Okay, another one. What would we do here? Well, we're going to multiply by square root of 3 over square root of 3. Multiply by 1, right? And what I get is 9 times the square root of 3 on top. Then I get square root of 3 times square root of 3 is a 3, but I had a 2 there as well. Okay, so I've got, actually what I've got is, let me simplify this by writing that 9 as 3 times 3. And then I have 2 times 3 on the bottom, so that I can cancel off this 1 right here. That 3 divided by 3 is a 1, so I can remove that from the fraction. 3 times the square root of 3 over 2 is what this simplifies to by rationalizing the denominator. Okay, another one. What we're going to do here is if the fraction's inside the square root, we're going to start by just separating it into separate square roots so that I can now multiply by the square root of the denominator. So I'll have the square root of 5 times the square root of 32 over 32. And then what is 5 times 32? I might have to do a little problem here. 32 times 5. 2 times 5 is 10, 15, 16. So it's the square root of 160 over 32. But I suspect that the square root of 160 can be simplified. So let's try simplifying that result. What does 160 simplify into? Let me just do that. Well, that's going to be, let's see, 4 divides into that. And then I get 40, right? And then does 40 simplify any further? Well, I think I could take another 4 out and get 10. And so that's going to be 4 times the square root of 10. So this numerator here is the same as 4 times the square root of 10. And hey, 32 is divisible by 4, right? It's 4 times 8. And so that means this can be written as the square root of 10 over 8. That would be the fully simplified form here. Okay? I know there's a lot going on. We're combining a lot of ideas, which is why this is such a large topic. What about this? Well, this one requires some explanation. Now, to rationalize, you would think I would multiply by the cube root of 5. But what is the cube root of 5 times the cube root of 5? That's not really going to work, right? Because I would get the cube root. Well, let's try that. Let's try it and see what happens. Let's multiply by cube root of 5 over cube root of 5. On the bottom, I'd have the cube root of 5 squared. But wait a second. That doesn't really cancel, right? In fact, it's really the cube root of 5 squared. And it doesn't cancel because this 3 and this 2 don't match, right? What I really need is I need to have a total of 3 5s being multiplied inside the radical there so that they can cancel. What I really need is I need this number inside here, right? When I multiply it by this number to be something cubed so that it will get canceled by that cube. So what I'm going to do is I'm going to make this 5 squared. Okay? And you'll see why in a second. Cube root of 5 squared. Okay? The reason for that is when I multiply now, I have 2 times the cube root of 5 squared. But now I have the cube root of 5 cubed, right? I had 1 5. I needed 2 more 5s to get 5 cubed because now the cube root and the cube cancel. And I have a positive, so I don't have any issues with the sign here. Okay, and that leaves me with the 5 down there. Okay, I can simplify a little more because what I have here is cube root of 25 over 5. Okay, so to get that cube root of 5 off the bottom, I had to multiply by something that would produce a 5 cubed so that I could use that cube to cancel the effect of the cube root. Okay, try this one, same idea. Okay, this is tricky, right? I have to multiply by something that will give me x to the 7th. So how many x's do I need? I need 5 more x's in order to do that. So what would I have? I'd have 7th root of x to the 5th, and then now I have the 7th root of x to the 7th, and those cancel, leaving just an x on the bottom. So it's 7th root of x to the 5th divided by x. Tricky. This is one of the trickiest cases of all for simplifying. Okay, here's another idea, same idea. What would I have to multiply by to get a 90th root to cancel? I need x to the 90th. So what do I need to add there? I need to add 70 more x's, right? 70 plus 20 is going to be 90. So then this will be 90th root of x to the 70th. And what will I have? I'll have 3 times the 90th root, 3 times the 90th root of x to the 70th power, and then this will cancel and leave just an x. I know that seems ridiculous, so I'm not going to say we encounter that a lot, but in case you do encounter it, you need to know how to handle it. Okay, what about this case? Let's try to multiply by just the square root of 3. Okay, if I try to do that, I'm going to have to multiply that square root of 3 times that entire denominator, right? So I have square root of 3 on the top, but I'd have 6 times the square root of 3 plus 3 times the square root of 3. Wait a second, because I had to distribute, the square root didn't go away on the bottom. So that's actually not effective, right? We can't do that. In fact, we don't want to do that. We don't want to multiply by just the square root of 3. Instead, we have to buy it by something else, okay? What we're going to do is we're going to form something called the conjugate. The conjugate. Now, the conjugate is formed by copying the 6 and copying the square root of 3 and changing that. If it's a negative, make it a plus, and if it's a plus, make it a negative. So we'll make it a negative. And again, because I'm trying to multiply by 1, I have to multiply the numerator by that as well. So what do I get if I multiply this out? On the top, I have 6 minus square root of 3. But on the bottom, I have to distribute. So I have this whole thing times 6, which is 36 minus 6 square root of 3. And then this whole thing times the square root of 3, which is plus 6 square root of 3. Positive square root of 3 times negative square root of 3 is a negative, and a square root of 3 times a square root of 3 is a 3. All right. So the reason why we use a conjugate is when you do that, when you use the same numbers but change the sign from plus to minus, you will always have this form of cancellation in the two terms that have a square root. So this is effectively makes those go away because I'm left with 36 minus 3, which is just a number, 6 minus square root of 3 over 33. And you might see it written that way, or potentially you could even see it written this way, right? Some people like to separate the square root from the non-square root. Both of those are valid ways to write that answer. But anyway, the procedure here is to multiply, not by the square root of 3, but by the conjugate of the entire denominator. Okay, so try the same idea. Look at this example. Pause it for a second, kind of digest it, and then try it on this problem right here. Okay, if you've tried this, this is what this should look like. You're going to take the conjugate of the denominator, which looks like this. And then when you multiply it out, you're going to get 2 square root of 7 minus 6, because the 2 has to multiply both of those. And then on the bottom, you're going to get square root of 7 times square root of 7, which is 7, right? And then you're going to get negative 3 square root of 7, positive 3 square root of 7, and then a negative 9 on the bottom. These will cancel because you used a conjugate. You'll have 2 square root of 7 minus 6 over 7 minus 9, which is 2 square root of 7 minus 6 over negative 2. And I am going to separate those to see that this is negative square root of 7 plus 3. Negative square root of 7 plus 3. Okay, again, we're pretty close to the end of the time of this 15-minute video here. We're going to go into another video here in just a second with additional examples and one more big topic to cover.